Morning, guys. How's everybody this morning?
Good.
Good. Today's lesson, guys, is going to be a hands-on lesson that we're going to do out in the lab. But first, I'm going to demonstrate this step by step for you all this morning. Okay. Today's lesson will be upon indicator lights in motor control circuits. Okay. Our previous lesson, we hooked a simple stop and start holding circuit up in our motor controls class. You guys have completed that, so this is the next step. We're installing indicator lights. Now, some of the objectives we're going to hit on today's lesson is we're going to be able to identify indicator lamps or lights, also where they're used, what their purpose is, and also how they function. Okay, so let's start with talking about the indicator lamps. Okay, this I have in my hand. This is the indicator lamps we'll be using today in our circuit. This is a 120 volts green indicator lamp. Okay, and also this is a 120 volt AC red indicator lamp. In today's lab activity, what you're going to have is I give you all a copy of your lab activity. Okay, now we'll have a stop and start button. We'll have a motor starter, a green and red light. What's going to happen is when I mash that start button, there will be a green light that comes on, indicating that the motor is running. Okay. When I hit the stop button, the green light will go off. The red light will turn on, indicating the motor is stopped. Okay. Now, any question on today's lab activity? First of all, let's start with saying, how are indicator lamps illustrated on our schematics? Anybody got an answer?
They have a circle and the 4 lines, and they have an indicator in the
Miss May says a circle with 4 lines coming to the side. That's correct, yes. And usually on our lab activities, we have what indicating what color?
The letter.
Yes, we have the letter G meaning what? Green. R meaning red. Good job, good job. What is some importance of indicator lamps in the industry, guys?
Safe.
Trent says safety. How can that, what do you mean by that, Trent? What do you mean?
It lets you know if something's running or not.
Exactly. Let you know if something's running or not. Yes, that is true. Okay, I'm going to start with, guys, I'm going to start with wiring this circuit. My first step, you guys can follow along on your schematics you have in front of you. My first step is to, what's my first step, guys?
To run your hot wire to your stop button.
Yes, Trent says to run my power wire over to where, Trent?
To stop, so it'll be your normal close.
Yes, my first step is to run a power wire over to my stop, which is a normally closed, as he said. So, stripping the wire back. What size wire are we dealing with, guys, this lab activity?
16.
Huh?
16 gauge.
14. It is 14. Now, obviously on your holding circuits, the first power wire goes to the stop button. Trent said on normally closed. Then, what's our next step, guys?
You are running out the other side of your stop button to your start.
Yes. Now, power's running into my stop button. Now, I'm coming out with another wire. Trent says going over to my start button. Yes, he is correct. Now, what is the status of that button? Is it open or is it closed?
Open.
Yes. The start button is open, he said. Yes, he said. That is correct. You guys see what I'm doing here? Okay. Now, I've got power ran into my stop button, as you see, on the closed side. Coming out of the closed side, now it's going over to, Trent said, the start button, which was, what state?
Normally open.
Normally open. That's right. Looks like my contacts. to my stop button. Now it must go where, guys? Look on your schematics, as we're following through this, where does it go out of my stop button?
To the other side.
Yes, to the motor starter on the coil, right? So the particular motor starter I'm using is
That's your two bottom, right?
two top, yes.
Two top.
So this is my coil, as you guys see here, on my starter, okay? Basically got an input and an output on my coil. So I'm gonna run the wire from my start button on the normally open side over to one side of my coil, okay? That's my very next step. Okay, now I'm going to secure this. I'm going to twist these in a clockwise fashion. Why do I always want to go clockwise when I twist wires together, guys? Put a cap on them?
So it'll connect the
Huh?
cap. So it'll connect the screw on.
Yes. What happens if I twist it counterclockwise?
It'll untwist.
Yes. So when I tighten my cap down on my wire, it will actually untwist it, right? That's a bad thing. We don't want that to happen, do we? Now, I have power going over to my coil on my starter. My next step is then to come out of the coil and go where?
Back to neutral.
To neutral.
Yes, back to the neutral. To complete the path, correct? Again, I'm really twisting these down, putting a cap to hold those securely. Okay, my neutral wire, I ran a white wire for it. Why, guys? You know, why is the difference that I ran white instead of black on my neutral?
His blind on his indicator neutral.
Yes, we associate white with neutral in 120 volt situations, right? Residential wire. This will be our power source, guys, to test this, okay? A simple test cord we have, the end cut off, wires exposed. Obviously, you guys know with a 120 volt system, we got a black, white, and a bare copper or ground, okay? So black is my power, white is my neutral, and green is my ground on this. So I'm connecting my white wire, this ring coming from my starter coil, back to my neutral, completing that path. Okay, now we have our connections made on that. Position these here. Okay, my next step then, guys, is creating my holding circuit on my circuit, which enables me to take my finger off of that start button and the motor continue running, right? What happens if we don't have that holding circuit, guys?
When you let off the button, it'll stop.
Trent says I let off the button, it'll stop. He's exactly right. Now, on your schematics, you see the holding circuit ties back in where?
Right before the start button.
Yes, before the start button, Travis. So the wire in between the stop and start is the one I must connect to, okay, on my holding circuit. So I'm going to loosen the screw, insert my wire under that, hold it securely, tighten it down. Now, for this holding circuit to work efficiently, where must it go? Where does this wire need to go? What do you guys think?
To the auxiliary contact on the motor starter.
Good, Travis. Yes, good. It goes to the auxiliary contact on the side of the motor starter. You guys can see on the side of the motor starter, I have a block. This block gives me the options of a normally open or a normally closed contact, okay? So for that holding circuit to work, it needs to go to the open side. So I'm going to simply insert it under the screw. Okay, now my next step is I'm coming out of my auxiliary contact block on an open and going to the opposite side of which button?
Your stop. Your stop button.
Opposite
Start,
side of the
start.
start, right? create that holding circuit around that start button. Because basically you're creating a path, a detour around that start button to be able to take your finger off that and that motor continue to run. Okay? So, now I'm going to insert it. See guys, this is my wire, my power wire coming in my stop. This is coming out, going to my auxiliary contact. Now I must insert this wire on this side of my normally open to make that connection complete. So we're putting 2 screws under this terminal. Now, this might be a little difficult, but what you want to do is you want to put 1 wire under one side and 1 wire under the opposite side of that screw. So when you tighten it down, the screw's in the middle between the 2 wires. You want to make sure that's secure, okay? Make sure that wire does not pop out of it. So now we have our holding circuit attached to our starter. The only thing left to do is insert our green light now. So our green light, we want to this particular lab activity, we want the green light to indicate when the motor's running. So, I want to connect the wire to the green light from the coil of a motor starter, okay? Not the neutral side. You want to connect on the opposite side, wire coming from the start button, correct? So I'm simply going to take the cap off my wire going to my coil, twist it in with it, and reinsert the cap on that. Now, what's my next step, guys? Looking at your print. I've tied it into the coil going to the starter. What's my next step? Tie it into the neutral, right? It has to have a neutral to make that line operate. So I'm simply taking the cap off the neutral side of my starter and tying it with that. So basically, when you get done, this is what you should have, okay? You should have your green light connected with the coil on your motor starter. You should have that right there. So now what's going to happen is when I hit this start button, this motor starter is going to engage, this green light's going to come on, the motor will run. Now, I want a light to indicate whenever I hit the stop button and the starter stop, I want a red light saying, hey, that motor is not running. And to do that, I'm simply going to use my red light and connect it on the auxiliary contact block again. But now, instead of using the opens, we're using the closed, okay? Good. So to do that, as you see on your schematics I gave you, I'm going to run a power wire directly from power over to a closed on that auxiliary contact block. Now, does it matter which side you go into on your contact block? Doesn't matter, does it?
No.
Just so you go in one side and you bust out of the other and go to that red light. Okay? So now I'm going to insert my red light on the opposite side of my contact block, which is closed. Now I have, what's my next step? What's the last step for that light to work, guys? Where must it go? What do you think, Travis?
Neutral.
Must tie back to neutral, right? Once it does that, your lamp will work. I can simply tie it in with the other neutrals. Okay, now our light is wired in to our circuits. Now our last step is running direct power to my starter for my motor, because we're going to be operating a simple 120 volt electric motor in this circuit. Now I must tie back into my direct power to do this. Okay? I run a direct power wire over to the top or bottom side of our starter, guys.
Top.
Yes, I always go in with power on the top side, and I come out the bottom and then go to the motor, correct? On a three-phase, if this was a three-phase system, we would have line 1, line 2, and line 3. But in this case, with 120 volt, we've got a hot wire and a neutral in the ground. Next step is running my neutral. Flip that off. You guys will do this in groups of 2, okay? So it's a little quicker than 2 of you working on it, rather than 1 like me, so be a little quicker. And I'm now twisting my ground wire to my source. Source ground. Run that over to the top of the starter.
Whenever you hook up the motor, you'll make sure you match them up, right?
What's that, Trina?
Whenever you hook up your motor on the other side of your motor starter, you gotta make sure you match them up, right?
Trent made a good point. He said, yes, whenever I connect my motor, I need to make sure I match those up. What he's meaning is, see my black is on the right side. See that? I need to make sure I come out of this block on the bottom with my black to my motor. I'm going to do a shortcut here. I'm going to simply plug these in here like this, so we can test this real quick. See it operate, then you guys will go out in the lab and hook your own up. We're going to make sure we connect black to black, white to white, and green to green, color coded. What happens if we misplace one of those wires, guys? Say we swap the black and the white, what's going to happen?
Short out.
Yes, short out. Okay, just now connect the last wire, which is the ground. Okay, now we have our circuit complete. Try to arrange these so you can see them. I'll do a quick test on this. Okay, everything's hooked up. We're going to test. Ready to see this operate, guys? Here we go. Now, what happens as soon as I plug power up there?
For light indicator.
Yes, so we have a red light indicating what?
It's not.
Motor's not running. I'll mash my start button. This red light should go off, green light should come on. Okay, here we go. Look at that. Red light went off, green light is now illuminated, you can see, indicating that, hey, our motor's running. Now, As soon as I hit the stop button, what's gonna happen?
So the lights are
Good. Motor's gonna stop, green light's gonna go off, red light's gonna come back on. Now, the true purpose of this circuit, guys, that you'll see in the industry is, say for instance, we have a rather large piece of equipment, or even maybe a piece of equipment in a different room somewhere, where we have a control station at one room and the actual components in the other. You need something indicated when that motor's running, because all the time you cannot be able, sometimes you won't be able to see that motor, so you need something indicating that for you, okay? So this circuit is widely used in the industry, and it's really, really important circuit. Any questions, guys? Good deal. Now, next step we must do is, we're gonna go in the lab and groups of 2, and we're gonna wire this up, okay? See it run.
Alright.
Thank you, guys.